Okay, today we're going to talk about special triangles. So, two special triangles that are going to come up big in trigonometry: 30, 60, 90, 45, 45, 90. Now, in geometry, what you learned with really the 30, 60, 90 is it doesn't matter how that thing is rotated, your shorter side is always across from the 30. That was considered x. Your hypotenuse in this 30, 60, 90 is always double that. And the long leg across from the 60 is always the short side times square root of 3. With a 45, 45, 90, what you should have learned is that that's an isosceles right triangle if the base angles are equal. So these were considered x, your legs, and your hypotenuse was always x square root of 2. Now, what did that mean? That really meant that, if I said this was 7, well, that means this would be 14, and this would be 7 square root of 3. If I said this was 5, that meant that was 5, that's 5 radical 2. You could do it backwards. If I told you this was 10, well, that means the short side would be 5, and that would be 5 square root of 3. Now, if I told you this was like 10, well, if you know a leg, you multiply by radical 2. So if you know the hypotenuse, you would divide by radical 2. But you can't have your fraction like that. So you multiply, you get 10 radical 2 over 2, which is 5 radical 2. So what happens in trig is really we make these x's the easiest thing we ever could. Well, the easiest number to make x, because really all these triangles are similar, they have the same angles, they're just a dilation or a getting bigger or smaller. So what we do is we say, let's assign x to be 1. Well, if I assign the short side as 1, the long side is 2 times 1, which is 2. The long leg is 1 times radical 3, which is radical 3. So what my students really remember about a 30, 60, 90 is I'll say to them, what's across from a 30? They say 1. What's across from a 60? Square root of 3. What's my hypotenuse? 2. I do the same thing with a 45, 45, 90. We make the legs 1. Well, that means the hypotenuse is radical 2. So what do students know about a 45, 45, 90? The legs are 1. The hypotenuse is radical 2. Now, what could I ask you? Any trig function of a special angle. So I could say any of that. What's the secant of 60 degrees? Well, you look at 60. Secant is reciprocal of cosine. The cosine would be 1 over 2, adjacent over hypotenuse. So the secant is 2 over 1. If I said, what's the cosine of 30 degrees? You look here. Cosine is adjacent over hypotenuse, radical 3 over 2. If I said, what's the tangent of 45 degrees? Opposite over adjacent, 1 over 1, which is 1. So special triangles, we want to get our heads around this. We want to label these x's. Now, on an ACT, you still should have that knowledge, but when you go to right triangle trigonometry, higher level, this is really what you want to know.